Hi, everyone, and welcome to a reflection about the use of airbags. Today, we're diving into the world of chemistry and safety to explore this life saving technology. When talking about airbags, we first have to note what exactly is an airbag. An airbag is usually used in many vehicles, such as cars, as the one I'm in right now, where it pumps out the car's steering wheel and dashboard in case of an emergency. This caution protects the user's body from major harm and allows us to save their lives in case of an accident. But have you ever wondered what exactly goes on inside those airbags to make them more so effective in saving lives? Well, follow us in this journey to solve that question. Starting by solving the question, well, the key that makes the airbag inflate is a reaction that happens inside the airbag. The main component of this reaction is what we call sodium azide, also known as NaN3. This component has been used since the first generation of airbags to create a tiny explosion that generates the entire reaction. This can be seen in the following image. This image shows the sodium iodide inside the airbag, which in this case is two molecules that break down into two products, sodium in its metal state and nitrogen gas, the former being the key to airbag expansion. Explain a little bit about how nitrogen affects the system. At the moment the gas is released, it fills the airbag pouch, causing it to expand really, really fast. The expansion is almost instantaneous, since it being fast is necessary to cushion the impact of the passengers. For this reaction to happen without issues, it is necessary to have a balanced reaction as seen in the image above, as well as have an appropriate amount of sodium azide inside the airbag. To determine the exact amount, it is necessary to know the stoichiometry and the thermochemical values of the reactions. These values can be seen in the following image. This image shows individual values of enthalpy, entropy, and Gibbs free energy of each of the components of the reaction. These individual values are important to find if the reaction is exothermic or endothermic, if the reaction disrupts the order of the system, or if it stabilizes it, and if it's in spontaneous or non-spontaneous. To determine what this is of the entire reaction and not just the products and the reactants, we use the following formulas. These formulas knows that the subtraction of the sum of the given measurement of the product against the sum of the reactants of the measurement, giving the overall measurement of the reaction. By applying these formulas with the values that we have on the first table that was shown, it is possible to find the exact values for enthalpy, entropy, Gibbs free energy of the entire reaction as seen on the following image. In this image, we can see the each of the values of the reaction that the entire reaction of the airbag produces. We can see that the reaction is exothermic, causing a disorder in the system as well as being spontaneous. This is known by looking at the signs of the measurement of the reaction. Knowing this fact about the stoichiometry and thermochemical values of the reaction involved in the airbag deployment provides valuable insight into the chemical processes that make airbags so efficient in protecting lives. The safety that an airbag produces also comes with some precautions, especially in the use of its materials. First, let's talk about sodium azide. Sodium azide is highly toxic and explosive is an explosive substance. Continuing with the products sodium metal and nitrogen gas, sodium metal is highly reactive and can ignite when exposed to air or water. Nitrogen gas, on the other hand, is colorless and odorless, which can displace oxygen in the air, leading to suffocation in some cases. So it's crucial to handle each of them with extreme care. Always wear appropriate personal protective equipment and work in a safe environment. Apart from causing harm to us, if managed incorrectly, the materials can pose environmental risks if handled in the same manner. The primary concern is sodium azide, the key component responsible for the rapid inflation of the airbags. Sodium acid is highly toxic to us and to the environment. It can destroy lakes, wildlife, and harm plants. To avoid this from happening, it is necessary to dispose of them correctly, as well as having a good transportation of the waste, as well as an authorized place where we can dispose of the compound. In conclusion, airbags are a primary example of how chemistry is applied to improve safety and protect human lives. The rapid decomposition of sodium azide, driven by chemical reactions, transform an inert material into a life-saving cushion in a fraction of seconds. This highlights the power of chemistry to manipulate matter and energy for the benefit of society. Chemistry is not just a subject confined to textbooks and laboratories. It's an integral part of our world and our daily lives, shaping the world around us and influencing our future. By understanding the fundamental principles of chemistry, we can better appreciate the importance of its power, and we can help us improve the state of humanity and our environment.